Hi everyone, thank you for viewing our poster. This project was a collaborative effort between myself, David Saltzman, a fellow graduate student, Sahil Luthra, and our advisors, Emily Myers and Jim Magnuson. Before I begin, after more reflection, we have reconsidered the implications of our results and the design of the monitoring paradigm, and therefore the conclusions we will present will be a bit milder than the stance of the title and abstract. Several experiments have found that listeners are slower to process speech when the talker changes from word to word in an unpredictable fashion. Historically, this has been taken as evidence of talker normalization, or the process of adjusting the mapping between acoustics and phonetics for each talker who vary substantially. This slowdown has been termed the multi-talker processing cost and is most often observed in the speeded word monitoring paradigm. In this paradigm, participants are presented with a rapid stream of spoken words and asked to indicate each time a target word was presented. There are two different kinds of trials. In block trials, all stimuli are produced by a single talker. In this example, ball is our target. Therefore, a participant would need to respond each time they heard ball. In contrast, are mixed trials, where two different talkers produce the distractor and target items, though the task is otherwise identical. Participants are slower to respond during mixed trials than block trials, which serves as evidence for an obligatory talker normalization process. We have identified two design features of the speeded monitoring paradigm that impede the development of automaticity, both of which were intentionally added in the original paradigm for this reason. Therefore, in this study, we asked which of these design features is necessary for observing multi-talker processing costs. The first feature is that in mixed talker trials, both talkers produce the target item, and therefore listeners have to monitor for two unique exemplars of the target compared to only a single one in the block talker trials. This was intentional, as it requires listeners in the mixed condition to engage in an active, controlled mode of processing. This added cognitive demand, unique to the mixed talker trials, could be the source of the multi-talker processing cost. We will eliminate this feature by changing mixed talker trials such that only a single talker produces the targets, but both still produce distractors. The second feature is that words serve as a target on one trial may be recycled later as a distractor. This inconsistent mapping between item and response was identified as an impediment to the formation of automaticity by Schneider and Schifrin. Though this target recycling is true of both the blocked and mixed talker trials, it may be that its impact is amplified by the attention and/or resource demands imposed by talker mixing. We will create consistent mappings between item and response by never allowing a target word to later serve as a distractor. To investigate if the features we identified are necessary to observe a multi-talker processing cost, we created a 2x2 design where we systematically manipulated these two design features. Across the top of the table is the number of talkers producing the target items, and on the left side is whether target recycling was present or not. For all experiments, we collected data from 44 participants. Overall, what we see is that in experiments 1 and 3, where both talkers in the mixed talker trials produce the target item, a multi-talker processing cost is observed. However, when we change the paradigm so that only a single talker produces those targets, as we did in experiments 2 and 4, the multi-talker processing costs go away. Therefore, we believe that this is the critical feature in the speeded monitoring paradigm for eliciting the multi-talker processing cost. From these results, we can conclude several things. The first is that the multi-talker processing costs in the speeded monitoring paradigm are driven by the presence of behaviorally relevant talker changes. If listeners do not need to respond to the talker change, they are not slowed by the presence of talker variability. This is likely the cases in experiment 2 and 4, where the talker who is not producing the target items was essentially irrelevant. Therefore, when one talker produces the target items, either talker normalization is not incurred because the second talker is effectively ignored, or it is not observable because normalization occurs automatically and cognitive demands are now lowered by having less items to keep in auditory working memory. Consistent with this notion is that in other paradigms like speeded phonetic judgment and word identification, which require participants to respond in every trial, multi-talker processing costs have been observed. Finally, as to the future of the speeded word monitoring paradigm, the standard design has inherent asymmetries between mixed talker and block talker trials that make it difficult to determine whether multi-talker processing costs are truly driven by an obligatory talker normalization mechanism. Therefore, additional studies are needed to distinguish talker changes from general variation. Thank you for your time, and please feel free to contact us with any questions.